Okay, should we start? So how many of you managed to access SAS one way or on your own computer, let's say? How many of you tried to access SAS on your own computer and didn't? How many of you went over to the computer, one of the computer labs, to access it? Okay, well, make sure you go and do this, right? This is the most useful thing you're ever going to learn in many of your courses, right? This will get you a job if you learn how to use it. So don't, and it'll be useful for all your other courses outside of that. So don't fool around. This is something you really need to, you should really, it's a skill that will be really important for you to learn how to use. And this course moves at some speed, and if you can't do this stuff, early stuff, you're going to get lost. And I ask you questions on every single test about how to write SAS programs, so you better know how to use it for all those reasons. If you haven't done the problem set also, you should be doing them, right? Now's the time to get on, and my guess is that you could probably spend, what, an hour? At the outside, 2 hours a week maybe on this course, I would imagine would be sufficient to keep you up and in good stead. And if you just leave it to lapse till the end, you're going to be in trouble. I know this stuff right now might seem easy, but you know what you'll find is time will flash by, and then you wouldn't have learned the early stuff, and then you'll be, you know, in trouble. So make sure you keep up. Okay, so what I've do typically the day of the tutorials, I'll post the answers to what the problem set was. This problem set wasn't much of a problem set. It was really largely just learning how to use SAS. And in most of the problem sets I'll have, you know, there'll be problems you need to do by hand, and then we'll also add some SAS programming stuff to it as well. So this one was focused largely on using SAS. Most of it, you just have to cut and paste stuff into SAS to get it to run. And so also, even if you got all the answers and you had no problem, look at the answers anyway, because sometimes I actually will add stuff, additional stuff that I didn't even ask in the problem set to the answers. Okay, so go online, find the answers. So that's true about this one. I put some additional SAS programming stuff into it. So let's look through this. And for those of you who were here last week, I'd already done this, right? As I said, it's just dragging you through doing it. So just as how many of you were here last tutorial? How many of you weren't here? How many of you can't remember? Okay, so some were here, some weren't. So I'll go over this again because I guess it wouldn't be bad to. Just as a reminder, here's a SAS data set. And so what's going to happen is if you've done enough of these, and you don't, how many is enough? 3? Once you've done some of these, the way in which you set up SAS is really always the same. So the statements at the top are going to define the data you're inputting. And with 3 or 4 exceptions, you're always going to put the data in where every individual in your data set, so every subject, every animal, every whatever it is, every person, is really going to be on one line. And then across the line are going to be things you measure on that person. So often in this course, we're only measuring one thing, you know, measure the height of everybody, or maybe 2 things. Are they male? So indicate whether they're male or female. What's their height? Or it could be, you know, male, height, weight, blood pressure, female, right? That's typically what data sets are going to look like. So here's an example data set where we've got, it's the cell phones, right? It's the weight of cell phones of males and females. That's the silly example we're doing here. And so you just give a name to the data set. So all SAS programs begin with the word data. So I put here in bold, that's a SAS keyword. And so SAS needs to see that. The first thing a SAS program needs to see is the word data, then a space, and then something you make up. Make it a word that's meaningful. Don't embed any spaces or special characters in it, just in case, because SAS might fail. So that's what I'm recommending. And then typically all lines end with a semicolon in SAS. The next line tells SAS what the variables are. So the word input is a SAS keyword, and then you make up the names of the variables. So in this data set, we had people's gender, whether they're male or female. So whenever you're inputting words or letters, typically categorical kinds of information, follow the name you make up with a $sign. That tells SAS these aren't going to be numbers, they're going to be words. And then the thing we're measuring, the numeric variable in this case, is weight. So make up a name. I called it weight. It could be mass. It could be anything you want to call it. But there's no $sign after it. That tells SAS, this is going to be a number. So I can, do arithmetic, various mathematical operations on numbers, right? So that's, and as I said, the design is going to be always the same, no matter, with minor exception, no matter what you're doing. You're doing a two-way analysis of variance, which we don't cover in this course anymore. Once you're finished this course, you can do a two-way analysis of variance. You would set up the data set exactly the same way with the right kind of variables in it, etc. And then the word cards or data lines. Cards, as I mentioned last day, is a carryover from the ancient days when to run a computer, you stuffed a bunch of computer cards into the computer. All these programming lines would be written. Each line would be on a different card. But this could be data lines. It makes a little more sense. And then the data follow, right? So every line is another individual in my sample, giving the same order of variables as in the input statement. So the gender first, then the weight, then the next individual, male, and so on. And then there's a bunch of stuff you can do. The things that come after the data set are called procedures, proc for short, and there's a whole bunch of them, right? And you have to learn how to call these different procedures. So one of them is sorting, so we might need to sort the data. Proc, so now the stuff we're doing in class, we're starting to do summary statistics or descriptive measures. So we can ask for the mean, we can ask for measures of spread, which we didn't cover last day, but will on Tuesday. The standard deviation, standard error. Proc univariate gives a whole bunch more, the kind of things we're going to be doing, etc. So some of this stuff we haven't covered yet in class, but we'll basically have done that probably by Tuesday. And so that's all described in here, right? And so that what you needed to do was that's all described in this data set. Again, I've just reiterated in the answer sheet what is in the data set. So let's just run it, just for those of you who weren't here. So all you need to do is kind of cut and paste this thing in, right? So here's the data set. And it might not be a bad idea that if you want to run SAS, let's say you're running it, you can't get it to run on your Mac or whatever it is for some bizarre reason. What you could always do is prepare all the programming statements in a Word document. And so then when you go over to the computer lab to run this stuff, you just cut and paste it from your Word document into SAS and run it there. So it would probably take you, 15 minutes to, just cut and paste stuff in. So it won't take you long to run it. Unless there's some errors in there. You might find some errors, you might have to do some corrections, but you could prepare it all beforehand, right? And so it will take no time to get in there. As long as you're able to get through the Tim Hortons coffee line, you should be okay. So I'm just going to cut and paste this into SAS. So and if you look at problem set 1, it also describes how you go about accessing SAS using WebFast. So if you want to still try to get it through your computer, as long as you have a connection, an Ethernet or Wi-Fi or whatever connection to your computer, you can do it from anywhere, right? With the proviso that, as I said, there are some operating systems / computers that for some reason this stuff doesn't want to run on. But there's always the odd student who we can't figure out what happened. So there, you just cut and paste it in. So remember, SAS has a couple of windows that load up. You want to put all your programming statements in the editor window, so that's what I've done here. And so we can run it. And so I've put a whole bunch of procedures one after the next. I don't need to. I could just put one at a time in and do it. So there's everything in there, right? And so now if I click run, this is what we did last day. It's worth going back and checking the log window. The log window, here it is here. It just spits out kind of what you gave it. It just reiterates what you've done. So it's telling me I had this data set. It tells me how many observations there were. There were 10 observations, so that's good, and 2 variables. So you can look at it, right? As I said, sometimes SAS will flag problems. Sometimes it won't. It won't the kind of mistake you make, it'll misinterpret. And so you want to check, are the correct number of observations? Were there really 10, n equals 10? Were there 2 variables or more than right? So look at that stuff, because sometimes it'll know that you've blown it, and sometimes it won't. Then it goes through all the procedures. It tells you what it's kind of doing. Here's another procedure it's running. So just look, and so, you want to kind of look for the word error or something like that. So that ran fine. And then if things run, it calls up this new window, the the results viewer. So the results are here. So this was the result of the first thing. It was just proc means. It calculated the mean. I asked it to calculate the mean. So there it is. The standard deviation, it's a measure of spread. And the standard error, it's a measure of how precisely we estimate the mean. So we haven't done those things yet, but we will. You've probably done that stuff. Probably in first year you should have, and probably in taken any other, even physics maybe, chemistry perhaps. You've calculated these things before. And then there's proc univariate. So this is another procedure that does the kind of statistics we're doing in class, all those measures of spread and location. So it gives the mean, it gives a standard deviation and variance, which you haven't covered, but we'll do next day. Standard error of the mean. It gives the median and a bunch of others, right? There's a whole host of things. Some of these we'll talk about. It gives quantile, so we'll refer basically, there's the median again. So we'll talk about some of that stuff. And then it writes out the 5 highest and the 5 lowest characters. So in some ways, it's also a good way of looking at, let's imagine you accidentally put the number 10,000 in here as a mistake. You might quickly see it because you'd find, man, the highest observation is 10,000. That can't be right. But you don't really want to be error checking. You want to check your errors, whether you transcribe things correctly before you run the program, but it's not a bad thing to do. And then I asked it to separately calculate means for each gender. So let me just jump back. So the statement that is there is this is proc means. I asked it to give me the mean, the sample size, the standard deviation, the standard error by gender. So for each gender. So that's what it's done here. And to do that, you have to make sure you first sort it by gender. So all that stuff is in there. And I'll talk about more of this stuff later on. But for now, it's just the getting familiar with using the program. So that was question 1, which really doesn't involve you doing anything other than just logging onto SAS and cutting and pasting this program in, right? That's all that's involved there. Shouldn't have been difficult. And then in here is just described all that stuff, what it means, what it's doing, and all that. And as I said, if you want, what I often do, if you really are doing this, because you could already use this for some of your other classes via lab courses, right? You want to calculate means and all that stuff, here it is. I normally will just cut and paste the results out rather than clicking the print button, because SAS really spews results out across many pages. So often just cut and paste this into a Word document, the bits I want, and then use that, for example. Okay, so let's move on. Eventually we'll get to things that I didn't provide you, I didn't go through before, that were stuff you had to figure out yourself. So this is still the result output that I cut and pasted into the Word document. Then we did this frequency plot stuff, right? We just plotted, so this was pertinent to the bar plots we were doing in class, right? So again, you're just cutting and pasting this program in and running it. I'll stick it in there anyway, even though it's sort of redundant because I did this last time. So, whoops, we want to go back to SAS. Here it is. You might want to clear the results viewer out. Otherwise, SAS it just keeps appending. If I run another program, it'll stick it at the bottom of this. So you can have it all there. There's no reason to clear it out, but I'll clear that out, and I'll clear this as well. And then I'll just cut and paste this new program in. So this new program, again, it just gives the data set a name. It's inputting a variable I called y. I could have called it something a little more exciting or relevant, like, because remember, these were each the roll of one dice, of a die. I could call it roll, so I'll change the name of that. Then we have data line, the data. And so because I changed the name, I got to put the word roll in here. So remember, in here, this is calling a procedure called frequency, which counts up the frequencies of things. And this tells it, so everything here, again, is SAS gibberish. But these are all SAS commands that say, I want tables for the variable roll, because I changed the name, I have to call it roll. And I want you to plot those as a frequency plot. That's kind of what all this stuff, with the exception of the word roll, which is the variable name I made up, right, is SAS stuff. And then you have to have the word run, and then if you run it, hopefully it'll work. And so we did this last day, and so it's plotting, so it's nicely already plotted a frequency distribution for you. So we have frequency, right, the count of the number of times when I rolled a die, it was 1, the number of times it was 2, 3, 4, etc. Right? We did that. And it also presents it as a frequency table, and in typical SAS fashion, it bludgeons you with all kinds of stuff that you might not have asked for. So here's the different rolls. You can have roll of 1, you can roll of 2, 3. Here are the actual frequencies, the counts. It does that as a percentage. It does the cumulative frequencies. So we talked about cumulative frequencies in class the other day. So you can see here are the cumulative frequencies. And then it calculates the cumulative frequencies as if it's a percentage. So it does a whole bunch of stuff. It gives you these by default. You could look up how to run proc frequency and ask for, a smaller subset of stuff. I often go with just the defaults because otherwise it becomes way too much stuff to remember, right? If you want to do specific things, you can just Google stuff on the web. I'm really giving you the minimal stuff I want you to know how to use, all right? So yeah, so you can really draw nice graphs right away, and again, cut and paste this into a Word document or PowerPoint or something. And you could, you can edit the axes if you like, etc. So let's clear that one out. I'll clear this. And let's go back to, so here we are. And then the final thing was, what was the final thing? Yeah, the final thing was this. So this one, did I do for you? No. So this one I didn't run last day. So I don't think I did anyway. Below are the numerical grades for students in a course entitled Extreme Basket Weaving for Non-Majors. And I wanted you to plot a histogram. And I sort of said, do it by hand. And I wasn't really serious. I hope nobody did do it by hand. Or if you did, good for you. Because it's a pain, right? Because if you do this by hand, the first thing you need to do is to put, because each of these is a grade, right? The grade that one student received. So student 1, 2, 3, and so on. So you need to put these into bins. You could do it like, by 10. So how many students got a grade between 20 and 30? So here's 1. You sort of have to look through the whole thing and find the number of students that got a grade between 10 and 20, 20 and 30, and so on. Right? It'd kill you to do it, but you could. And the other thing here, and as I said last day, there's a lot of data here. I wanted to give you a lot of data, so when you draw a histogram, it's sort of relatively meaningful. Right? So that's why I gave you a lot of data. And I could have written it, should really have written it all as one single column with each student on the line. But because I didn't want it to stretch down for 5 pages, which we could have done, I instead strung students out. So here's student 1, 2, 3 across lines. And if ever you input stuff that way, you have to tell SAS that that's the way you're doing it. Because SAS really expects every individual on a separate line. If you do an exception to that, you have to put the symbol, these two @ symbols after the variable you're inputting. Right? So I never want you to use this format on a test. Okay? On a test, I always want you to use the other format where every individual is a line. There's only these exceptionally few questions I'll ask you which involve a lot of data where you need to use these two @ symbols. Okay? I don't want you to use it because it can lead to some kind of form of confusion. And logically, it's better to have the consistent format of input where every individual is always on another line. Okay? And the variables you measure go across the line. So this is an exception to that. And then it tells you that you need to change its input statement in this way, and it also tells you what the procedure is called, how to call the procedure to draw a histogram. So you needed to manage to put that together yourself. So let's kind of do that. So I'm going to cut and paste the data in to SAS. So there's the data, Control C, go back to SAS. Here it is. So there's the data set. And so I line stuff into columns. You don't have to. Right? As long as there's one space between each number, SAS, that's what SAS does. It looks for a space. It sees a number, and as soon as it sees a space, it says, okay, now there's another, that's a new individual, and so on. It's sometimes nice, though, if you do line things up in columns, because then it's easier to spot errors and it's more organized. And so typically when I'm doing analyses, I use SAS quite a bit. I typically input the data on Excel in an Excel spreadsheet, and then I just cut and paste the data from an Excel spreadsheet into SAS. So that's kind of what I normally do. Because it's already, Excel is nicely set up in columns, in rows and columns. So I input the data that way. When I come to SAS, I just cut and paste it in and then add the SAS statements I need. Okay, so let's call this something. So what was, and you can use upper or lowercase. It doesn't really matter. I think I tend to use uppercase. So data, this was like basket weaving or something, right? We'll call it baskets. And so we're inputting, and these are all grades, right? So let's call them grades, call them anything you like. And so now, whoops, and so the mistake I already made is I have to put these two thingies after it, these two @ symbols, that tells SAS to look across. Here's individual 1, then 2, then 3, then 4, then 5. The next number it sees, it's going to be individual 6, and so on. And so then we need the data lines, or it doesn't matter, card statement. Data lines is, I guess, a little more meaningful. Cards is shorter to write if you're lazy. So that's that bit. So we've now defined the data set. Now, just out of curiosity, remember I ran proc print the other day. If you just want to print out the data set, you just say proc print, and then say run. Let's just do that and see what it does. Because what it's probably going to do is to print out a really long single column of them. There it is, right? So it immediately, you can see it's read the stuff incorrectly. It's put them all in a line, right? Here's individual 1 and the grade, 2, 3, and all the way down. I don't even know how many there are in here. Yeah, 255. Okay, so that's if you wanted to look at the data, you can always, to see that you've inputted correctly, you can always ask it to print it out. So I didn't ask you to do that, but it might not be a bad thing to do. And so now we need to run the programming code to run the program we really want, and that is we really want it to draw a histogram. And so let me get rid of this statement. So it's proc univariate is the procedure we'll use. So proc univariate also gives you a whole bunch of descriptive statistics. Right? The stuff we started doing in class last day. It'll give you the mean, the variances, and all kinds of stuff. And the histogram statement here is part of, it's an option within proc univariate. So you don't have to indent it. Sometimes it's a good idea to indent things, so it's as a reminder that it's a part of proc univariate. So it's histogram, so you're asking to draw a histogram slash, and this gibberish here is really just SAS code, vscale equals count. So this is all SAS stuff. It tells, make the y-axis the actual frequency of individuals, the actual count of individuals. You could put the word percent in here, and it would plot the y-axis as the percentage of individuals. Or you could put proportion in which case it gives you the proportion of the relative frequency. So it'll just change the y-axis, right? So the numbers on the y-axis will be different. The histograms will look exactly the same, of course, but the axes will be, the y-axis will be different. So that's what we can do that, and so if we run that, so it gives, so the first thing it gives is all this proc univariate, the stuff we're doing in class. Now, the mean, it tells you how many, the sum of the observations, the sample size, skewness and kurtosis. So I won't have you, remember I talked about skewed distributions, whether they're skewed to the right or skewed to the left, or positively skewed or negatively skewed. There's actually a statistic that measures skew. So we won't really cover that, but it's worth knowing, and proc univariate will tell you that the distribution we're going to look at is ever so slightly skewed to the left, negatively skewed. Kurtosis is another thing. It's whether or not the distribution is too flat or too peaked, so I won't really go over that, but just so you know what these things are. The normal distribution, right, there's an equation that describes it, and so kurtosis is a measure of whether the histogram is too flat relative to the normal distribution or too peaked. So those are some other measures. And there's a bunch of other stuff in here, some of which we'll talk about, some of which we won't. I'll come back to that. Interquartile range is one we will talk about. So there's a whole bunch of stuff in here. And then finally the histogram, which at least for this portion of the problem set was what we were trying to do. Can we draw a histogram? And so you can see maybe there's a slight skew negative, right? This bit is skinnier than that part. I can kind of more easily grab the left side with my hand. So right, it does a nice histogram, and as I said, if you're doing gotten any data collected in another class, and you can quickly kind of do this thing and just cut and paste the things out, or save it down. I think, yeah, save picture as. You can probably save it down as some kind of BMP, some form of file, and then just load it into, insert it into a Word document or whatever you happen to use through your write-up. Okay, so there's that. And so there's one other thing that we can do. I think I'll cover it later. So that's what I asked you to do. So you needed to put a couple of things together yourself. It shouldn't have been mind-numbing. You had to write a slightly different input statement for that. Did anybody manage to do this? Yeah? Sorry? Different? Okay. Yeah, okay. But as I said, make sure you do these things. It's going to be the most useful thing you learn in university. Yeah. Maybe an overstatement, but really this, if you learn how to use this program, I'm telling you, it'll be very valuable for all your other courses, and B, it'll give you something that, some marketability outside of biology. There's all kinds of, data analyses kind of stuff that needs to be done in all kinds of businesses and marketing and who knows what, right? And typically your average professor won't know how to analyze any of their own data, so you could kind of, help them do that if you happen to get a job or work in somebody's lab. Okay, so where are we? Yeah, so there's another thing you can do, and that is you can actually ask SAS to plot the normal distribution on top of your histogram. And so that's a nice visual way of seeing whether or not you've managed to, so I'm just going to skip down because I can't remember what exactly the gibberish is for doing that. So let's have a look. It's just probably /normal. Yeah. Hist grade normal. So let's go back to the SAS. So let's go back here for a moment. And so it turns out that if you see if I get this right. I quickly looked at my notes. All I've done is to change the sort of what I'm calling for. So I've told it to do a histogram for grade, which it would probably do by default anyway, because there is only one variable in there. /normal tells it, I hope, to plot the normal distribution, like so if the data were really normally distributed, on top of the histogram, I hope. And it failed. Oh no, it didn't. There it is. So there it is. So this is kind of really nice, right? So this gives you, it's not a rigorous, let's say, statistical way of seeing whether or not your data, right, the histogram, which represents the real data, the grade distribution of that particular class, but you have a real pictorial view of whether or not that data follow the theoretical normal distribution, the bell-shaped curve. And it's pretty good, right? It's not maybe quite as peaked as it should be, and this side is good. It's not a bad match, right? So that's a nice way of seeing, because one of the assumptions many analyses we're going to do in this course is that the data follow, or at least are not too far away from the normal distribution. And if that's so, we can really get a nice pictorial view of that. So it'd be a nice way of even already presenting data if you have, you need a reasonable amount of data. You need a reasonable sample size in order to get a reasonable result, to get a histogram that already isn't too bumpy, but you can kind of do that right away. So that's a real useful thing to be able to do, right? In proc univariate, ask it to plot a normal distribution on top. Okay, and so let's continue on. So that was additional, something I hadn't asked you to do in the original problem set, but I've embedded that additional SAS code in the answers to the problem set. So make sure you go on the website and look at the answers and get that additional thing in there. So this is the one we just did, right? The next thing you had to do was, what was the next thing you had to do? Below, so this was the other thing I didn't do. You just had to put some stuff together. Below you find letter grades for a course entitled Advanced Pedagogical Babble. Plot the distribution of these data by hand. Again, I didn't expect you to do it by hand necessarily. And if you did do it by hand, you would have to go through and count up the number of F's, B's, A, B, C, right? You'd count them all up and then plot a bar plot, which probably isn't that horrible to do, but, do it on the computer, it's easier. So we have to use the proc-freq stuff that we used before in the smaller example I gave you with die. So let's cut and paste this stuff in. So there it is. So we go back, go back to SAS. I'll clear this out. Edit, clear all. I'll clear the results viewer, edit, clear all, go back to here. Oops, here's my editor window. So there's the data. So now again, this is another one of those exceptions where I've written people's grades strewn across lines just because I didn't want to have a super long column, 250 some odd lines long, right? So let's define this data set. So data, what was it, something to do with pedagogobabble. Pedagog, input, I'll call it let grade for letter grade. And because these are not numbers, right, I have to put a $sign in. So that tells SAS, these aren't numbers. These are like categorical data. In the computer gibberish, you'd call them alphanumeric data. Right? There's things, they're not numbers, I guess is what that means. And remember, I need the two ampersand, the two at symbols, and then data lines. So as I said, this is pretty standard, right? Defining the data set. If you do enough of these, you don't have to think anymore about how to define the data set. So there's the data set defined. Now we need to run procfreak. So you have to look up how to do that. Incidentally, remember, I sometimes put a semicolon after the data. You don't need it, but I throw it in there. Procfreak. And so now it's the table statement. I can't for the life of me remember it, so we'll look it up. So it was the same statements you needed to use in the other procfreak with the dice example. So here we go. Procfreak, we want tables. Oh yeah, and all this stuff. So there we go. So we want tables. What did I call it? I didn't call it letter. I called it let grade. So I have to make sure that whatever is written here is what's written in my input statement. So let grade. And then the rest of it is SAS. It's asking it to do a frequency plot. And then remember, you need the word run down here. And then you click the little running person icon up here. And hopefully it'll run. And so there it is. A very strange distribution of grades. But let me just check the log window. Yeah, it looks like we didn't blow it. 250 observations. Right, so there's the frequency distribution. And there are ways of manipulating the, like I don't know if you want A over here or A on that side. You know, if you really wanted to fancy this up or make it, change the order, there are ways to do that. I'm not going to show you those kind of things because it just ends up piling on too much stuff that I don't want to focus on. But you can always just go Google proc frequency, frequency plots, and there'll be tons of information on how to change these axes. You can probably draw different colors on it and a whole bunch of other stuff. Okay? Yeah. So if I were to use proc univariate, so we'll try it. So if I were to use proc univariate for these data, proc univariate alone is expecting numbers. So it will become very unhappy. And I suspect it wouldn't be able to draw a histogram either. Yeah, it won't draw it. Yeah, so proc univariate and histogram is for numeric data. If you have categorical data, like these, right, you want to draw, you're going to use proc frequency. Exactly. And so the easy way to do it is to just, if you're sitting there at SAS, just try it. Right? It doesn't cost you anything to mess around and see what happens. Probably also worth making that mistake just to see what kind of error it gives you, because sometimes errors are cryptic. Like there's an error there, but the way in which it describes the error, it might not twig to you what exactly the heck it's talking about. So it's worth making some mistakes, intentionally or unintentionally, and seeing what it says. Okay, so that's proc. So we've done proc freak. So those were the things that were assigned in quotation marks in the problem set. So make sure you do those things, right? And so then I've added some additional stuff. Okay, so drawing other kinds of plots. So some of it is relevant to the stuff we talked about in class. So here's a way of, if you want to do scatter plots, so you have two numeric variables you measure on each individual. So this is a data set where someone has gone out and measured the height and weight of a bunch of individuals, some of whom are males and some are females. So we have three variables here, right? One categorical variable the gender, or I called it sex in this case, and then the height and the weight. So every individual is on a line. First we have the gender, so I use the word sex, $. It's telling SAS I'm inputting letters or alphanumeric. So typically for categorical data, I'm typically going to use a $sign after the variable. It doesn't have to be, but typically that's the sensible way to do it. And certainly if you're inputting words or anything with a letter in it that isn't a number, you've got to put a $sign after the name of the variable you make up. And then the height and the weight of each individual. So that's the data set defined. And if you want to, you can just use all this gibberish to do a scatter plot. There are other ways of doing scatter plots that will sometimes automatically pop up. I'll talk about that towards the end of the course. But this is one way of doing it. And so everything in here is SAS gibberish. I'm calling a particular kind of procedure for plotting stuff. It's asking for a scatter plot. It's telling me the x-axis. So here's the only thing I changed. I wanted on the x-axis height, so I stuck height, the variable height, on x equals height. The y-axis I wanted to be weight, so I put y equals weight. And then we've got group equals sex. So it's actually going to put a different color or different point or something for the different genders. Okay, so it's going to plot, all the points are going to be on the same pair of axes, but they'll be colored differently. I can't remember. Either colored differently or a different symbol or something. So this is kind of, again, another useful thing you can do if you need to do scatter plots right away. You don't have to think very hard. You just have to define the data set and stuff the right variable names in down here. Right? If you had, like, if I had 3 genders, if I had males, females, and hermaphrodites, you know, it would be exactly the same thing, right? And so it would be 3 different colors of points or something. Yes? You have to, so the x equals thing is SAS gibberish. I have to tell it which variable is I want, because I could switch these around. Here I'm telling it I want height as the x-axis, I want weight as the y. I could flip it around. It'd be curious to know what happened if I didn't put that in. It might or might not run. It might just throw them in by default. I don't know. I could try it and see. So let's see what happens if we do this. So let's clear this thing out and run it. So there it is. It's a kind of ugly-ish because there's not a lot of data there, but the idea here wasn't to give you a lot of data, it was to show. So here it is. Here's height on this axis. The females are in red, and the male points, I think it's blue. There they are. So you have a scatter plot. So there's not a lot of data in here. It doesn't matter. But you can see, you can really nicely already, if you had a reasonable amount of data, get some nice plots done. And out of curiosity, let's see what happens if we leave out, if I don't define. Like, for example, if I took this away, it would just plot points all of one color, right? I'm not going to define the group. So let's just do that for a moment. So here I'll just throw all the individuals in. It won't distinguish males and females, I imagine. So there it is, yeah, just plots points, they're all the same color. So you could do that if you wanted to. Or if you don't have groups, that's the way you would input it, right? You have a bunch of data. You want a scatter plot like that example I gave in class. Numbers of flowers, numbers of bees visiting them, you just have a scatter plot. There's no distinguishing into different groups. And so I'm just curious to see what happens if I don't define the axes. I have a feeling it will be unhappy, but who knows? Yeah, nothing seemed to happen, did it? So if I go to my log, whoops, syntax error. So, you know, it needs expecting one of the following x comma y. Statement will be, so it didn't do anything. So sometimes it gives you a semi-sensible error, often in red, that you can interpret. So yeah, I can't drop, I need to tell it what the axes are, which variable should be x, which should be y. And it'd be useful, because imagine you had a data set where you had, you know, a better number of individuals, let's imagine, and a bunch of variables, height, weight, you know, elbow width, you know, whatever, blood pressure, some other stuff, right? And you didn't want to plot everything against everything else. You could do a bunch of plots where, all right, I want elbow width against, you know, the length of your hair, or, you know, whatever, right? You can just tell it to plot ones explicitly that you're interested in. Even though you had a much bigger data set, I don't want to see everything plotted. I want to see that against that. I want that against that, whatever, right? You can do all that kind of stuff. And as I said, I'm giving you sort of minimal ways of doing things because, you know, I don't want to inundate you with all the gibberish you need to drive these programs. If you, start using these and you find you want to do something more, then, go on SAS and go on Google and just Google SAS, SGPlot, Like, for example, in these things, like, the points are kind of small. Maybe you want them bigger. Maybe you don't like the colors. Maybe you want them filled in. There are probably ways of telling it, I want bigger point, how to, but we don't need to worry about that, right? Or, yeah. So you can do all that kind of stuff, but I'm not as part of this course, right? If you want to fancy these up for your later work. It's easy to find and learn how to read the SAS help files that are on the web. Okay, so I think there's just one other thing maybe in there, I can't remember. And then I want to tell you a little bit more about SAS stuff that isn't in problem set 1. Okay, so there's another way of graphing data where it plots it as separate panels. You can read through that yourself and kind of do it yourself. Again, this is stuff that's sort of additional to what I want you to take home. So this is sort of like these plots are a little fancier, maybe than you need to worry about, at least this one for this course. It plots these scatter plots as separate panels. So there's a little more, put the genders into different panels, into different, right? That's what it's going to do here. So everything else is the same except for this one statement here. So let's do that. Right, so it sort of draws them separately, but kind of on the same figure. So here's the females over here, right, plotted, and then the males are over here. So again, this would have to do with the aesthetics. If I'm going to, have some data, some experimental results, is it useful? Is this a useful way of portraying these data to the reader? Is this good, or does this get some point across? Is it aesthetically valuable to do it this way, or is this kind of thing more meaningful, plotting them on the same axis? And it doesn't really matter to me. It's for you. Is it aesthetically better? Does it get the point across that you're trying to read, that you want the reader to get hold of, right? To my mind, maybe this is kind of a better way. You can kind of see the females are kind of squished down towards this end, and then, they're in the lower quadrant generally of the axes of height and weight, not surprisingly. And males tend to be bigger and kind of even more spread out. I mean, this is a tiny data set, and it's just made up anyway, right? If it had more points, it'd be a little more meaningful, but it's really just to illustrate how to do these kinds of things. Okay, so that's everything that was in problem set 1, I think. There's one other thing. Yeah, so let's go back, because this tells you, remember I was talking about cumulative frequency distributions? So instead of plotting a histogram for numerical data, how to plot the cumulative frequency distribution. So you do that really almost the same way you do histograms. So let's do that. So you're going to go back and you're going to run that that data on, what the heck was it? Grades in basket weaving, yeah. So it's exactly the same data set. The basket weaving grades, percentage grades. Proc univariate, what you're asking for instead of a histogram this time is the cumulative frequency distribution. So the letters for that are C, D, F. I have no idea why they're in red. Normally when SAS puts stuff in red, when it makes it red, I didn't make it red. When it makes it red, it's sort of flagging an error. So I'm telling it I want a cumulative frequency distribution of grade. I think that will work. It used to work, so let's run that. And so there it is, right? It nicely draws cumulative frequency distribution. Right? So as I told you before, if something is roughly normally distributed, if you have a histogram that's normally distributed, but you present it as a cumulative frequency distribution, and here it's the cumulative percentage, it should kind of look sigmoidal in shape. And in fact, we can also plot on top of that, I think if you put the word /normal, it'll plot the normal distribution on top of it, but the normal distribution as represented as if it was also the cumulative frequency distribution. So let's do that, see if it runs. Yes. So it's hard to see, but there's a solid line on here that represents the theoretical normal distribution when it itself is portrayed as a cumulative frequency distribution. And so you can really nicely see how closely these data mesh with the normal distribution. So it's really kind of also a nice way maybe of getting a visual inspection of whether your data follow a normal distribution. And so, as I said before, we don't look at cumulative frequency distributions a lot. We see them a lot in survivorship data, where people are, they're growing a bunch of fruit flies. They've inserted some different genes in fruit flies to expand their lifespan. There's a lot of work on fruit flies, not to make fruit flies live longer, but to find out, to investigate the genes that might be responsible for increasing longevity. So you might have strains of flies with different genes in them or different mutants in them or stuff like that, and you grow them all and you measure, how many are alive at day one, when they die, right? And so that's often presented as cumulative frequency distributions. So you could plot many of these curves all on one graph, and you get a nice picture simultaneously of you had 10 different mutant strains of flies. You could look at them all at once on one pair of axes. So that's very useful to do as well. So you can plot a cumulative frequency distribution quite easily using SAS or a histogram, and you can plot the theoretical normal distribution that best fits those data on top of it to get a pictorial view of whether or not your data mesh with the normal distribution. So that's kind of really handy to do. So that's it for that. But I want to just introduce and talk about a few other things in SAS. So if you go back to the website, here we are. So there's the answers I've posted. There's something here called some potentially useful operations in SAS. So I think I already opened that, but let's open it again. It's worth looking at that because this gives you some of the kinds of mathematical or arithmetic mathematical operations you can do in SAS. Okay, so if you want to square or take the cube or something of some variable, this is how you do it. You go y equals x asterisk asterisk to the 2. That would be y equals x squared. You can sort of write that equation right into SAS and compute a new variable based on something you've input. So if I input weight and I want the square of weight, I can use an equation like this. Or if I want to multiply two variables, I've input lengths and widths and I want areas, I can just multiply them with an asterisk. Or divide things, or add them, or subtract them, right? All those kind of things you can do in SAS to manipulate variables mathematically in some way. You can take absolute values and exponentiate, right? So these things are useful to know. And and you can also do things that are conditional statements. So if you've taken computer programming of some kind, you often use conditional statements, which involve if statements or if-then statements. If something is true, then do this, right? So those can be written into SAS as well, and I'll have you do some rudimentary if-then statements as well in the next problem set. So that's all listed out here in this document. So but I just want to quickly bring up problem set 2. I thought I didn't download it. I downloaded, but then I shut down. I just want to quickly look at problem set 2 because it has some stuff in it that I just want to go over in terms of SAS. So this problem set, I haven't covered all the stuff you need to do it in class yet, but we will have done it by Thursday, certainly. For each data set below, do these by hand. So these things you need to do by hand because on the test, you're going to be doing things by hand. And by hand, I mean with a calculator. Okay, so you're getting all these descriptive statistics you need to do. Here are the data sets. And then I ask you to do it on SAS as well. And so the SAS for much of this stuff we've already covered. For most of this stuff, you can just run proc univariate. It'll spit out all this stuff. Right? So you need to know how to input this data set and get the mean and all that other junk. And if you just run proc univariate on that data set, you'll get more or less everything you need. And the same is probably true for this. And yeah, this one, we often manipulate and transform data in various ways. Explore the effects of transformation of the data using the data of fish species A by adding 5 to each data point, or multiplying each point by 10, or taking the square root and all that. So let me just show you where that goes in a SAS program. So that stuff I just showed you. So let's go to the top of this. Let's imagine we're working on this grade. So here's here's the input. We're inputting people's grades. And I want to manipulate these grades because I think the class I think the grades are too high, and I want to be mean. So I'm going to subtract 25 from everybody's grade, just because I'm mean. So to do that, but after the input statement, but before the data lines statement, that's where you can do all kinds of manipulations. You can do all kinds of, any of those arithmetic things I just talked about, you can do all those things in here, right between them. So if I want to subtract 25 from everybody's grade, because I think the grades are all too high, or the dean yelled at me because my grades were too high, so I say, okay, I'll subtract 25 from everybody's grade. This guy will have 1.5. So how do I do that? Make up a new variable name. So call it anything. Call it bad grades, something. Call it anything. Equals grade, so whatever I call the original variable, minus 25. Not rocket science. Right? So that what's going to happen is it's going to go through, it's going to pick up everybody's grade, and then it's going to create a new variable, which is going to be the grade with 25 subtracted from it. So you can do all kinds of those manipulations in here. You can subtract things, or, maybe I feel sorry for the class, so I add 3 to everybody's grade, being very stingy. Right? So made up a new variable name, called it 3 plus grade, so everybody gets an additional 3. Or, I don't know, I want to confuse everybody, so I take the square root of everybody's grade, call it something, grade, I'll call it grade, can call it anything you want, grade SQ, equals, so now you need to know what the SAS gibberish is for taking the square root of a grade. So I don't know, where is that sheet? Here it is. So it is SQRT. So I need to know that. Whoops. So I got grade equals SQRT bracket grade. All right, so now, if I would actually run this, I'll have the grades transformed into various different things. And so let's just, what I'm going to do is, let's just run this. No, let's not run it. Let's run it as a histogram. See what happens. Whoops, doesn't like my spelling. Histogram. There we go. See if this will run. And so what it's going to do is it's going to plot, I hope it's going to plot this for all the grades I did. So there's the bad grade distribution. It'll first plot it for the untransformed grade, proc univariate grade, so it does it for grade. There's the normal distribution. Then it does it for bad grades. So here the mean is 35.8, not very good. And then it'll do the histogram for bad grades. Still looks like a normal distribution, right? It shouldn't change the shape of the distribution, right? It'll just shift it that way, right? And now we've got bad grade. So here, what did I do? Oh, that's bad grade there. Happy grade, what did I do? I added 3. So it should, be shifted a bit that way, right? The shape of the distribution should look exactly the same. It's just moving this way, right? And then we did, that's the happy grade summary statistics. Then the square root of grade. This really did bad things. So the mean, you can see, is going to be really low, like 7.7. And the shape of the distribution might also change a bit. So when you add or subtract, or even when you add or subtract, you won't change the shape of the histogram. It'll just be pushed one way or the other. When you start doing sort of nonlinear kind of things, like taking the square roots or the logarithm, the shape of the distribution itself can also change. Although here it still looks pretty much skewed left. It doesn't look that different. All right, so just the point I really wanted to make is in SAS, you can do all kinds of manipulations in here. And this is also where you put if, then, else. So those if statements. So look up how to do an if statement, because an if statement might be a conditional. Like if I'm really, if I'm really nice, I might say, if grade equals, let's do it this way. If grade is less than 50, I don't want to. I don't want to put a. Well, let me do it. I'm going to change it. Let's see if this works. Then grade equals 60. That might run. So what this might do is anyone who got a 50, it's going to look at all the grades. Anyone who got a grade of less than 50, it's going to give them a grade of 60. I hope. And let's take this junk out of here. The reason I really didn't want to do this is I'm actually changing. I wanted to create a new variable. Let's run this. And we shouldn't see any grades less than 50. Let's hope. And yeah, so here we go. We can see, remember this is well, there we go. It's a very funny looking distribution. The unfortunate people who got grades between 50 and 60, their grades didn't improve, but everybody who had 50 or lower got a grade of 60 or more, which is kind of a stupid thing to do. And that's probably why you see this unduly large peak at 60, in the 60 range, because everyone else who really failed, I decided to give them a 60. So this is I don't do this. You wouldn't really do this, but the point I'm making is that's how you use these if statements. In an if statement, you typically would want to create a new variable. So it might be better to say something like this. If grade is less than 50, then make up a new variable. Call the variable failure. And I'm going to put in the word failure. I don't know if that'll work or not. It turned everything purple. If everything turns purple, there we go. So what I've done is I've said if grade is less than 50, I've created a new variable. I've given that new variable the name 50. And that new variable really, even though there's no $ after it, because I'm assigning to it something in quotation marks, that means it's a word. SAS is going to say, this must be like a categorical, an alphanumeric variable. So anyone who got less than 50, it should write the word failure, maybe, beside them. Let's just out of curiosity print that out. So I'm just going to say proc print. So I'm winging it a bit here, but let's see what happens. Yeah, it's there. So it's printed out the data, and anyone who got less than a 50, the word failure is written beside it. So I'm not asking you to do that for for the problem set 2, but that's that's an example of how you use an if-then statement. You need to use the if-then statements. Where is that problem set? You need to use that if-then statement for, here, for this example. Okay, so that's an example of how you use it. How many of you have done some computer programming, coding? Okay, I mean, in Excel also has if-then-else constructs. They kind of work the same within the context of a spreadsheet, but I don't know, probably all computer programming languages have if-then conditional statements. So go through and mess with that. So they're really useful things to do, right? If you input data in one format, you want to change it, or you want to, for a course, I want to say, or this person, or a sign. If I have numbers, if I have grades like this, where are my grades? If I have grades, and I want to convert them to letters, I can get SAS to do that, right? I can just say, if grade is less than, if grade is greater than 50 but less than 55, then let grade equals D. If grade is a 55 to 60, then let grade equals D plus, right? You could do those assignments right here. In the class, and probably all our science classes, we always have numerical grades. We have to convert them to letters for the thing. So you could do the conversion right using SAS, right? Did you have a question, anybody? No? Okay, so that's just what I want to do, just to set you off on what you might need to do. The only things that are different, really, involving SAS in the next problem set. And then there's a bunch of stuff you need to do by hand. We haven't covered it all, but none of it is rocket science in particular. But make sure you do these, right? As I said, the problem sets, these problem sets in some ways represent the minimal amount of, problems that you need to do. If you calculate, if you feel comfortable calculating means and variances and coefficient of variation and all that stuff after having done 4 examples, then stop. If you need to do a few more, do it. You need to practice doing these things, right? Just like anything. Because you want to be, this fundamental early stuff, you should know how to do it almost, while asleep. Because that'll then set you up for being able to do the more, somewhat challenging stuff that we're going to do later on. Because you need some facility for doing these, so when you look at the equation for sample variance, you kind of know easily, even if you don't remember it, you know easily how to calculate it, right? You know how to work that equation. So make sure you do a bunch of these things, and make sure you learn how to use the SAS, both because I ask you questions on how to use it on the test, and it's it's a really valuable tool. Okay? So I'll hang around if anyone has any other questions also. All right?